Here we're asked to simplify inverse tangent of negative 1. Now what that really means is that inverse tangent of negative 1 is going to be equal to our angle theta, whatever theta happens to be. We do know that it has to be between negative pi over 2 and pi over 2. And with inverse tangent, we can't be equal to either the pi over 2 or negative pi over 2. Now this tells us that theta is going to be in either quadrant 1 or quadrant 4. Because if you look at our angles, we start at 0 here and we go up to pi over 2, and you're all the way around here to pi, and then typically we would go down to 3 pi over 2 before coming back up to 2 pi. That's when we're moving with a theta as a positive angle measure. Remember, so that's if we're going counterclockwise. If we proceed to go regular clockwise from 0 and we go down, now that's our negative pi over 2. So this region right here is where we're going to have our answer to this inverse trig problem. Now with inverse tangent of negative 1 giving us our angle theta, what that really means is that the tangent of theta is going to be equal to a negative 1. And in tangent theta equaling negative 1, that gives us something to work with. Now we know how tangent has to be in either quadrant 1 or 4 for our final answer here. Now if tangent's going to be negative, that's probably going to suggest we're going to be here in quadrant 4, but let's take a quick look at what quadrants will produce us a negative tangent. Here tangent's going to be negative in quadrant 2, but if our angle theta is in here, that's going to put us beyond our known restrictions of being in either quadrant 1 or 4. All right, so we know we're not going to use our theta from quadrant 2. All right. So that leaves us looking at what happens when theta is in quadrant 4. Here's our reference angle for theta. So in order to get a tangent that theta that's equal to a negative 1, that means our sine and cosine values have to be the same if we're looking at tangent of theta as sine theta over cosine theta, or we can just look at tangent of theta directly as the opposite over the adjacent side of our triangle here. So if we're going to get a 1 out of this, or admittedly a negative 1, but if it's going to give us a 1, that means that these two things here, the opposite and the adjacent angle, have to be the same. The only time that happens is in a 45, 45, 90 right triangle. Except we're going to move away from degrees here and use radians. So that means our reference angle here is pi over 4. And that'll give us an adjacent side of 1 and an opposite side of typically 1. But because we're in quadrant 4, that means we're in negative 1. Our y values are going to be negative. Now the hypotenuse, if you care, is the square root of 2. But really we're going to focus on that opposite and adjacent side. Now if we were to look at our regular theta from here, and we're going all the way around until we get into quadrant 4. Now we know the reference angle, again, was pi over 4. So going in the positive direction, that tells us that our angle measure would be 7 pi over 4. And it is true that the tangent of 7 pi over 4 is equal to negative 1. The only problem is that is incorrect for our purposes here, because it violates our restriction here that our angle theta has to be between negative pi over 2 and pi over 2. Now, that doesn't mean that all of our work up to this point has been in vain. What it does mean, though, is we need to take a different tack to figure this thing out. So instead of going all the way around the circle until we get to quadrant 4, in the positive direction, we're going to switch gears and just go in the negative direction. Now, our reference angle is still pi over 4, but because we went clockwise now, that means it is in fact a negative pi over 4. So it's also true that tangent of negative pi over 4 is our negative 1. Negative pi over 4 does fall within our interval of negative pi over 2 to pi over 2, so that is our answer for theta. For tangent inverse of negative 1, that's going to give us our angle of negative pi over 4. Now we're looking to find the arctan of the square root of 3. If you don't like the arctan look, arctan is the same thing as inverse tangent, so we're looking at the inverse tangent of the positive square root of 3. Regardless of whether you're using arctan or inverse tan, the answer is going to be the same. It's going to be an angle, which we typically refer to as theta. And there are restrictions on where theta is allowed to live. In this case, it has to be between negative pi over 2 and pi over 2. Which means that theta is going to be in either quadrant 1 or quadrant 4, depending on how this is all shaping up. Now, inverse tangent of the square root of 3 equals theta. Remember what this means is that the tangent of our angle theta is going to be equal to the positive square root of 3. Now, since tangent is equal to the positive square root of 3, that tells us that theta has to be in quadrant 1, because that's where our trig values are all positive. In this case, that's what also lines up with our restriction here, that theta has to be in either quadrant 1 or quadrant 4. And specifically, if the angle has to be between negative pi over 2 and pi over 2, that means we're going to be in quadrant 1. So that's where we're going to focus right now. Right, so if tangent of theta has to be equal to the square root of 3, now I know that tangent is equal to sine over cosine. However, I'm really not a fan of using that particular representation for tangent for these types of problems. What I would much rather look at is just a basic right triangle. And here's my angle theta, and I'm going to view the tangent as the opposite side over the adjacent side. So we're going to call this the square root of 3 over 1, just for the sake of visualization. And so that's how we're going to label this thing accordingly. So the opposite side would be our square root of 3, and the adjacent side would be 1. If you want to go through the Pythagorean theorem, it will tell you that the hypotenuse is positive 2. That's pretty much irrelevant to our concerns here. But if you're a completist, that's what you get. All that we're left to deal with now is to just figure out what angle generates this particular right triangle with sides of 1, square root of 3, and a hypotenuse of 2. And that's going to be our 30, 60, 90 triangle. Now keep in mind this drawing isn't necessarily to scale. And in this case, yeah, this would be our 60-degree angle for our theta here. But we want this to be in radians, so that's going to be positive pi over 3, which means that here if we go back and say tangent of pi over 3 is equal to square root of 3, that's true and easy enough to verify using your graphing calculator or any other number of means you may have learned to this point. And so that tells us then that our inverse tangent of square root of 3 is going to give us an answer of pi over 3. And if you prefer to write the answer in the original form of arctan, that's also okay. So the arctan of square root of 3 is also this angle pi over 3. For this problem, we're trying to figure out the inverse cosine of square root of 3 over 2. Now remember that answers to inverse trig functions are angles, so we're going to call this our angle theta. We have restrictions for inverse cosine, and that is where theta is going to be between 0 and pi, which means our angle theta is in either quadrant 1 or quadrant 2. So we're going to keep that in mind as we go through and do our work here. Since we're looking at the inverse cosine of positive square root of 3 over 2, since we're looking at the inverse cosine of positive square root of 3 over 2 to be providing our angle theta, that tells us that the cosine of theta is got to be the thing that generates that positive square root of 3 over 2. Now, since cosine is going to be a positive answer, that tells us then that our triangle, and thus theta, has to be in quadrant 1. Now we know that because cosine is positive in quadrants 1 and 4, but our restriction for cosine tells us that we have to be in either quadrant 1 or 2, and so where those two conditions overlap is going to be our quadrant 1. So that's where we're going to draw our triangle. Alright, so here's our right triangle, here's our reference angle theta, and now we know that cosine is the opposite, or excuse me, is the adjacent over the hypotenuse, so the adjacent side has got to be our square root of 3, our hypotenuse has got to be 2, and for the sake of completeness, if you want to use the Pythagorean theorem, that'll tell you the remaining side is 1, although in this case it's mildly helpful, so it's usually a good idea to finish that out. It helps us to identify more easily which triangle this might be of the known, or the ones that you're expected to know anyways for the purpose of this class. And in this case, the right triangle we're looking at is a 30, 60, 90 triangle. We know that because that's where our square root of 3 is going to come from for the triangles we're expected to know anyways. So now the question becomes, where is our angle theta? Is it the 30 or the 60 degrees? Now, since the side opposite of theta is positive 1, and that's the smallest one of our three sides, that's going to get the smallest angle, which would be 30 degrees, or in radians, positive pi over 6. As luck would have it, the cosine of pi over 6 is in fact positive square root of 3 over 2. So that means the inverse cosine of positive square root of 3 over 2 has got to be equal to that pi over 6. And so that's our answer. For this problem, we're looking at the arc cosine of negative 1/2. Arc cosine, that's the same thing as cosine inverse. Still the negative 1/2. And the answer to an inverse trig function is always going to be angle theta. So here for inverse cosine of negative 1/2 to give us our angle theta, we have to remember the restrictions on the range of answers for inverse cosine. That's going to be where theta is going to be between 0 and pi. So that means our angle theta is going to be in quadrant 1 or quadrant 2. As with arc cosine equal to negative 1/2, or if you prefer inverse cosine of negative 1/2 to give us our angle theta, that tells us that the cosine of theta has got to be equal to that negative 1/2. since cosine is giving us a negative value, cosines are only negative in quadrants 2 or 3, and our restrictions that we know at for the range on inverse cosine is that it has to be in either quadrant 1 or quadrant 2. The intersection of those two particular candidates is quadrant 2. Right, so that's where we're going to draw our right triangle. And this is clearly not to scale. It's barely a functional triangle, but that's what we're going to work with here. All right, so there's our reference angle for theta. They're coming up in quadrant 2. And we know cosine is the opposite, or excuse me, cosine is the adjacent over the hypotenuse. So that's where we're going to label our two sides. If we want to finish out with the Pythagorean theorem, that tells us our missing side is the positive square root of 3. Now remember that adjacent side is negative 1 because we're in quadrant 2 where the x values are negative. Now we have to just rely on the I'm sure masterful knowledge you might have now of the right triangles used for some of the common angles in trig, and that's going to be the 30, 60, 90 triangle or the 45, 45, 90 triangle. The one that's going to give us the square root of 3 in it is our 30, 60, 90 triangle. Now the way I tend to view these is to look for the smallest side to be opposite the smallest angle. Alright, so our smallest side here would be length 1, so the smallest angle, our 30 degrees, would be that upper corner. So that tells us our reference angle is going to be our 60 degrees, or in this case that would be pi over 3, but that's not the proper measure. That's only our reference angle. What we want to know is the distance all the way around here. Now when we're measuring these, we go from 0 up to pi over 2 on the positive y-axis. Then at the negative x-axis, we're there at pi. And so if you look at pi and we subtract off that that pi over 3, excuse me, that'll give us an angle of 2 pi over 3. So we can verify that cosine of 2 pi over 3 is in fact equal to a negative 1/2. So what that means is that our cosine of negative 1/2, or if you'd rather write it as the inverse cosine of negative 1/2, has got to be that angle 2 pi over 3. Or we're asked to find the inverse sine of negative square root of 2 over 2. Now remember, the answer for an inverse trig function is an angle, so that's what we're going to call theta here. Now for inverse sine, our restrictions for where theta can live are between negative pi over 2 and pi over 2. That tells us theta is going to be in either quadrant 1 or quadrant 4. Now, sine inverse of negative pi. Now, sine inverse of negative square root of 2 over 2 to equal our angle theta means that the sine of theta is equal to our negative square root of 2 over 2. Now with sine being equal to a negative number here, and our choice for quadrants to live in being 1 or 4, sine is going to have to be negative in quadrants 3 or 4, so it means that for this particular problem we're in quadrant 4. So here's our right triangle in quadrant 4. Here's our reference angle for theta. Right now remember, sine is the opposite over the hypotenuse, so that'll be a negative square root of 2 for the opposite side, and the hypotenuse will be 2. Now through the Pythagorean theorem here we can go through and find that our missing adjacent side is the positive square root of 2. And if you're thinking back to your two major right triangles that are used for the major angles for problems like this, that would be the 45-45-90 triangle or the 30-60-90 triangle. Now with the 45-45-90 triangle, I'll just draw this as if it were in quadrant 1. Right, our sides are 1, 1 and square root of 2. And for the 30-60-90 triangle, we have sides of 1, square root of 3, and positive 2. And on the face of it, neither one of those two triangles looks like the one that we're looking for. There's in a situation where we have two sides with a square root of 2 for each of the two legs. However, what's actually happened here is we are in fact dealing with that 45-45-90 triangle. So what's happened is that the initial problem presented our ratio for our sine, the ratio of two sides, with the denominator rationalized, which means they multiplied top and bottom by something to get rid of the radical out of the denominator. So if we go back to our 45-45-90 triangle and we look at that guy in quadrant 2 with our typical arrangement of sides, and we're still in quadrant 4, so we'll have our y value, the leg coming off the x-axis, as a negative value, so that'll be a negative 1. And we use this as our reference for theta. We can see that sine of theta is equal to negative 1 over, whoops, that should be square root of 2, not just the number 2. It's negative 1 over the square root of 2, which if we were to rationalize, we would multiply at the top and bottom both by square root of 2, so that's where this negative radical 2 over 2 is coming from for our answer for sine theta. So now remember, I mentioned before that this was the 45-45-90 triangle, which means this is our reference angle, which would be 45 degrees. We want this to be in radians, so that would be pi over 4. But that's a reference angle. To change it to what we're looking for, can either go one of two directions. We can go all the way around the circle, which would give us 7 pi over 4. But that answer is a loser because that is outside of our restricted range for inverse sine. So the only other option left available to us is to just go in the negative direction. We start at 0 and go down. And that would just mean that our angle here, instead of being 45 degrees or positive pi over 4, since we're going down this direction, is a negative pi over 4. And again, you can verify using your knowledge of the unit circle or graphing calculator or what have you to verify that the sine of negative pi over 4 is going to be that negative 1 over square root of 2, which when rationalized is negative radical 2 over 2. So that means that our final answer here for sine inverse of negative square root of 2 over 2 is negative pi over 4.